Hey, hello, how's everybody doing? It's Jono from Seneca Prep, and today I'm going to be talking through the different fundamental particles that you need to know for the SAT chemistry subject test. Some may even say I will put the fun in fundamental, but who knows? We'll see. You'll have to be the judge of that. Let me know what you think of this episode. So, we're diving straight in with some history of atomic theory. Yup, you thought it was chemistry, you've also got to know some history. So, our understanding of atoms has changed over time, and we need to know four key scientists, or maybe four key scientists, all men, sorry about it, who contributed a lot to our understanding of the atom. So we're starting off with John Dalton. He was an English school teacher. That was a hard word to say. English school teacher. Who first wrote that atoms were the basic unit of chemistry. He thought that atoms were spherical and different spheres constituted different elements. And he thought atoms were the fundamental unit of matter and were indivisible. Okay, let's see how that worked out for John Dalton. Let's go forward a little bit and talk about J.J. Thompson. So, 90 years after Dalton's ideas, 90 years, that's a long time. It's like my granny. J.J. Thompson discovered that atoms were divisible. He discovered and measured the mass of the electron. So Thompson, he did loads of stuff on the electron that comes up a lot as a multiple choice question in the SAT chemistry subject test. The electron was measured to be several orders of magnitude lighter than an atom, proving that smaller particles than atoms existed. How curious. This led to the Plum Pudding model, delicious, where the atom was viewed to be a largely positively charged sphere with embedded, smaller, negatively charged electrons. So the electrons were the plums in the pudding. This is just making me hungry. Next, we need to talk about Ernest Rutherford, and he fired alpha particles at a thin film of gold because clearly had nothing better to do with his life. If the Plum Pudding model were true, the particles would have been deflected by the gold, but instead most of them passed straight through the film. Now this led to the nuclear model, where the atom was viewed as being mostly empty space, with a positive nucleus and orbiting electrons. Fab. Now we get to Niels Bohr. Not boring, don't worry, it's quite exciting. The nuclear model had a problem. Oh, what was the problem, I hear you ask? Well, classically, an electron should spiral into the nucleus and the atom should collapse. But Niels Bohr solved this problem by developing the first quantum theory of the atom. Oh my gosh. With electrons assigned to fixed orbitals of defined energy. When electrons move between orbits, they must emit or absorb electromagnetic radiation of a particular frequency. Great. So, who disproved the Plum Pudding model of the atom as a result of an experiment with gold foil? Do we remember? I think it was Rutherford. Yes! Great, so good. Let's go over the features of the Bohr model. It's outdated, but it's still useful. Still useful, I promise. It has a positive nucleus containing protons and neutrons. Protons and neutrons, they're always in the nucleus, so in the cute little center, they like to be friends. And electrons are fixed in orbits. Let's now talk about some subatomic particles. So, atoms are made of protons, neutrons, and electrons. They're a great little trio. And these different particles, they've got different properties and characteristics, and I'm going to go through them now. But first, we need to talk about units. They're so small that conventional SI units like grams are like completely useless. So, for example, a proton weighs, I don't even know, like it's so small. It's like 1.67 times 10 to the minus 27 kg. Honey, that is not a nice number. That's not what we want to be using. So we use carbon. Carbon comes up a lot. And basically, we say the atomic mass unit, AMU, is defined as 1/12 the mass of a single carbon-12 atom. The elementary charge unit, E, is equal to the charge on an electron. The more you know. Okay, so now let's go through these different subatomic particles. So we've got the proton, that has a mass of 1 AMU. If you want to be specific, it's like 1.0073. Honey, just learn it as 1 AMU, and it has a charge of plus 1 E. Next, we go into our neutral neutrons. They also have a mass of 1 AMU, so the same mass as a proton. Slightly different, it's like 1.0087 AMU, but don't worry too much about it. Just know that both of them weigh 1 AMU. And neutron has no electric charge, it's neutral. So it's slightly heavier. So like we said, it's slightly heavier than a proton, but the difference is so small that we say both are equal to 1 AMU. That's what you need to know for the SAT chemistry subject test. Next, we're going over electrons. Now, they have a charge of -1 e, and the mass of an electron is so small, it's usually approximated to 0. But it's actually like 0.00005 AMU. So it does have a mass, but it's pretty much always like written as 0. Sorry, electrons. You're still atomic particles too. Justice for electrons. So the heaviest, now if you want to be specific, protons are the heaviest. No, neutrons are the heaviest, then protons, then electrons. Boom. But remember, we say that even though neutrons are slightly heavier than protons, we approximate them both to have an atomic relative mass of 1 AMU. Bam. And an electron has a low mass. Remember that we basically say an electron is 0. Okay, now we are centering ourselves. Take a deep breath. We're talking about the nucleus. It's in the center of the atom. And the nucleus of an atom contains the protons and neutrons. Just like your own center, it should be positive. So the nucleus should be positive. Gosh, that was cringe. Sorry about it. I just went with it. Most of the mass of the atom is in the nucleus, and the nucleus is positively charged. So let's just summarize that real quick. Nucleus contains protons and neutrons. It's in the center of the atom. It's where most of the mass in the atom is found, and it is positively charged because it's got them protons. Then we've got our electron shells, which are further split into subshells. More on that in an upcoming episode. And each subshell has a slightly different energy. Some are like, oh my gosh, so much energy. Some are like, yeah, I've got a bit of energy. Others are like, nah, I'm chill. I've got like my pina colada. I'm sitting by the beach. I'm on summer vacation. So all those electron shells, they have a different energy. Sorry if you can hear that weird scraping sound. That's just a chair. I need to put my leg up. It's gone a bit dead. So those are electron shells. So let's have a look at this atom. Those red particles are going to be protons. So if you're wondering what I'm talking about, protons are in the middle of an atom, as are neutrons. They're in the nucleus. So let's recap that. And then those electrons, they orbit the nucleus in shells. So what was that mass of an electron? Do you remember? It's tiny. It's like 0.0005 AMU. Let's recap some of those models from earlier on in this episode. So remember, the Bohr model assigns electrons to fixed orbitals of defined energy, and to move between orbits, electrons must emit or absorb electromagnetic radiation of a particular frequency. Let's go over those 3 subatomic particles we need to know. Remember, we've got a proton with a mass of 1 and a charge of 1, a neutron with a mass of 1 and a charge of 0, and then electrons have a mass of basically 0 and a charge of -1. Okay, so the atom has changed over time. We've had all those different models. We had our Plum Pudding model, our nuclear model, our Bohr model, and our quantum theory model. So much modeling. I feel like I'm Tyra Banks right now. So many models. What? That was a good joke. So that brings us to the end of this session. And we're just going to quickly recap the contents of atoms to finish. Remember, we have our nucleus, which has protons and neutrons, and then our electron shells, which are made of subshells. Subshells are made of orbitals, and orbitals are made of electrons. Don't worry if that sounds terrifying. We're going to be breaking down the structure of electron shells in future episodes. So you got it. You're going to be just fine. Thank you very much for joining this episode on Seneca Prep. I've been Jono. Keep up to date on updates. That was just repetition. Wordiness, not good for the AZT. We do AZT stuff too. You should check it out. Good luck with your studying. Keep up your hard work. And thank you for tuning in. Bye.